Okay, hello everyone. So I thought of making this quick short video, the lecture, especially for the lab you guys just did. It's the one-dimensional motion lab. I got several emails, mostly asking about the acceleration. So I thought I'll make another short lecture to explain some of the common questions. Hopefully this will help. So the questions I noticed that you guys having, um, so I have written them down here. So is the acceleration and velocity same? How do I know the car is accelerating? Is acceleration is constant all the time? How do I find the acceleration in this particular activity? And how to graph acceleration in particular? Okay, so let's go one by one. These are all very good questions, valid questions. Okay, so is the acceleration and velocity the same? No, they are completely different things. They're both vectors. Velocity means, the idea of velocity is it's like how far you go in a given time, right? Velocity is found by dividing the displacement by time. The idea of acceleration is, if you have an acceleration that tells you this velocity is changing, it's not a constant velocity. Acceleration is the change in velocity over time. The velocity, if the velocity is changing, that means there is acceleration. The vehicle is accelerating, it's changing the velocity. If it goes at a constant velocity, like those motorized cars you saw the other day, the blue Jeep or the red Jeep, they are constant velocity vehicles, so they do not have any acceleration, right? Acceleration is zero. But when you place the unmotorized one, that metallic one with 4 small wheels, the one that doesn't have a motor, when you put it on the ramp, on that inclined track, it speeds up down the track, right? That means there is acceleration. So acceleration and velocity is not the same thing. They have different units. Acceleration is measured in meters per second squared. Velocity is measured in meters per seconds. Now, when you place the cart on this inclined track, so looks like this, right? The first one we had 1.5 degree angle. So it's speeding up down the track. It starts from v initial equals 0, and over here it has some high velocity which we don't know, we couldn't measure it, but it has a big number. So the velocity is changing, so it's changing, like you have some v here, you have little bigger v here, you have even bigger v here, and you have the highest v over here. So the velocity is increasing, means you have a acceleration. So how do I know the car is accelerating? If the speed is, now visually you can see it's speeding up, you know that it's accelerating. It's going downhill without applying brakes, it's accelerating. Now another common question was, is the acceleration constant all the time? Yes, acceleration is constant. It's the same magnitude throughout. Now how do I know that? For acceleration to change over time, think about it this way. You have a ramp, it has the same angle, it's 1.5 degrees throughout. So let me okay, let's draw it here. So here's that 1.5 degree ramp, and later you increased it to a higher angle like this. I'm exaggerating the size of the angle here, right? These are not this big. So when you have 1.5 degrees, you have some acceleration throughout. It's constant, whatever the value is, it remains constant. Yeah, as long as the angle is same, this acceleration does not change. Now when you place it on a higher angle, you get a bigger acceleration and it remains constant. Whatever that big number is, it stays the same. But there is acceleration. It's not zero. There is some number and it remains the same. Now, how do you change the acceleration while it's moving? Only one way to do it is if you have a ramp like this, goes at some angle and then it changes like this. Let's say this is your ramp, right? It's bent here. So then you place the cart like this and you let it go. So it will accelerate at some level all the way up to this point, and once the cart passing this point, the acceleration will increase. If the angle increases, then only acceleration increases. So yes, although the velocity is changing all the time, acceleration remains the same for a given angle. Now let me clear all this and answer the next two questions. How do I find the acceleration and how do I graph it? Okay, the questions were how to find and how to graph. Alright, how do you find the acceleration? In general, the definition is acceleration is change in velocity over time. So let's say on this ramp, the car is speeding down the ramp, right? So let's say it's here and then sometime later it's here. So one way to do this is, we didn't do this in the lab, right? We did this in a little different way. So there's another way to do it. So you measure the velocity at this point, let's say point 1, and measure the velocity at point 1 and point 2. Let's call this V1, V2, or you can call them V initial, V final, right? If you measure the velocity at this point, let's say you have like a speed gun, like you know that police officers use to measure your velocity and give you speeding tickets. If you aim a speed gun at this point, right here, here's the speed gun, and then aim the speed gun over here also. I don't know, the diagram doesn't look very good, but imagine that you are excuse me, aiming a speed gun at the car at two different points, and you measure the time. Let's say it takes like 5 seconds from point 1 to point 2. So you measure the two velocities and you take the difference and divide it by the time, you get acceleration. That is one way to do this. Okay, so that is one way to do this, but that's not how we did it in this lab, right? We did it in a little different way. So this is one method. This is the general definition of acceleration, the change in velocity over time. To do this, you need to know two velocities. So in our lab, we had the ramp at first part, it was at 1.5 degrees. We release it at the very top. We didn't have a speed gun to measure the speed at different points, right? What we did was we let it go all the way to the end of the ramp and we measure the total time and we measure the total distance, total displacement, which is 210 centimeters from top to the end. We also had the initial velocity. We know that since we're going to release it from rest, initially it's 0. But we didn't know the velocity at any other point. We didn't have a second velocity. So for this lab, since all we have is V initial, time and displacement, right, these three things, we have to go with a kinematic equation. So the equation that works here is displacement equals V initial t plus half at squared. This equation, we have the time which we measured, I don't remember the numbers, but something like 2.6 seconds, I think, something around that. So that's the time. Initially 0, displacement is 210 centimeters, which is 2.1 meters, right? So you plug these numbers, you can find the acceleration. So this is how we found acceleration for this activity, because we didn't have two different velocities, right? That's that. How do you graph the acceleration? Now you see, no matter how many times you solve this equation, you get the same number, right? Acceleration is constant, it does not change. So it's is constant. So this is for 1.5 degrees. Now if you do the same thing, if you measure the time for 3.5 degrees, you will see that it's a shorter time interval. So you will end up having a bigger acceleration, which is again a constant, a bigger constant. So how do you plot a constant acceleration? How do you draw the graph? So here's the time axis, here's the acceleration axis, meters per second squared. Now whatever that acceleration is, you calculate the number, whether it's 2 meters per second squared or whether it's 0.5 meters per second squared, whatever that is, you mark it on this side, and then it has to be a horizontal line. Because it's constant, it does not change over time. So starting from 0 to whatever that end time, maybe it's 2.5 seconds, right, it's going to be a horizontal line. And there was another question, what is the maximum acceleration we can get? So let me make some space here. Now you see that you have some angle, you get some acceleration, right? You increase the angle, acceleration gets bigger. You make it even steeper, you get even bigger. So as you increase the angle, the acceleration increases. So what's the highest you can get? If you place it at, trying to draw a straight line here, 90 degrees. For some reason I can't draw it, but the idea is you keep this ramp vertical, perpendicular to the floor. It's almost like not having a ramp at all. You just drop the cart, which we wouldn't do in this lab. But imagine some object that was earlier rolling along the ramp, now it's just on a free fall. That's the key word, free fall, right? Keep the ramp at 90 degrees means it's just going to fall straight down. It's a free fall. That's the highest acceleration you can get. So what is that acceleration? That is acceleration due to gravity. Okay, I think this helps. So I'm going to stop here, but if you have further questions, feel free to ask me. All right, thank you.